Now here we have to prove a given equivalence without using truth tables. So without using truth tables, show that P double implies Q is equivalent to P and Q or negation P and negation Q. So what it means is we can of course always prepare a truth table and make all the required columns and say that the two specific columns are same which correspond to left hand side and right hand side, but that will take time and it will be a bit tedious. So rather than that, the other more compact way is to use the different laws that we studied earlier. So let us do that. Let us start off with LHS. Now LHS is given to be a double implication, that is P double implies Q. Now that is equivalent to, we know that is P implies Q and Q implies P, isn't it? So we write that. If you see on the right hand side there is no implication, so that gives us a clue that we have to somehow replace the implication, we have to replace that arrow with some equivalent statement. And we have seen in the conditional law that P implies Q can be written as negation P or Q, right? That's the first part. And similarly we do the replacement in the second part, that is negation Q or P. Now you see there is OR inside the individual two square brackets and the two brackets are connected with the AND. So this is where we open the brackets using distributive law. So here what we do is first negation P and negation Q. Then we do negation P and P. So therefore here we have negation P and P. Then we do Q and negation Q. And lastly we do Q and P. So we move on. So the first statement we keep as it is, because if you observe the right hand side that we have to adjust, we have already got this particular portion, isn't it? So now we don't touch that, we just keep it as it is. We move on. Now you see we have P and negation P. So in the AND, if we have two opposite truth values, that is P and negation P, then obviously one of them has to be false, isn't it? And in the AND operation, if one of the value is false, then clearly the whole answer has to be false. So we move on. Similarly here also we have Q and negation Q. So one of them has to be false, that gives the answer as false. Or here we have Q and P as it is. If we want, we can just write them by using commutative law as P and Q, which is same as Q and P. Okay. So now let us associate the first and the last together, because if you see throughout we have OR operation, so we can use the associative law to associate first and the last parts first. So we write it as P and Q, which is incidentally the remaining part that we had wanted on the right side, or negation P and negation Q, right? Okay. Now if we merge false or false, we know that false or false is nothing but false only, and hence when you consider this particular big expression, which is RHS or the false, that gives us the existing first expression only. And this is where lastly we use what is called as the identity law, that is some statement or false is same as equivalent to the statement itself, and this is nothing but the RHS. So this is how we use the laws to prove the equivalences without using truth tables.